looking into one segment or one part of it. You know, it has got a head, right, and body and tail. If I complete it, right, and it is present in the vicinity or curve of this red colored shown duodenum, right, the part of small intestine. Okay. Now this organ is retroperitoneal. Now you've got very good concept of peritoneum. So lies along your posterior abdominal wall. Okay. Now what else you observe here? These are the organs that are associated with your GIT. Because the food we take in, this type of organs, they are supposed to produce major enzymes in it and the hormones that are supposed to act upon the food we take. Because if I complete this, there should be the stomach over that, right? We take food, so and so, and if I complete here, there would be the liver. And what do you see? The left and right hepatic duct, just in a repeat, they're forming the common hepatic duct, right? And here you observe that pear-shaped gallbladder. That is meant for what? What is the function of gallbladder? Bile storage. Yeah. The bile storage. It means whenever we eat fatty food, so that should be supposed to pour its stored inside content, right, into this through its gastric duct that will combine with the common hepatic duct to form CBD, common bile duct, to carry the bile towards the duodenum. And here, today's topic is the pancreas, and in which you can see the main pancreatic duct as well as the accessory pancreatic duct. They are entering and opening into the second part of duodenum through the minor duodenal papilla and of course the major duodenal papilla, right? Here you call that it is being covered by the inside the sphincter foci, right? And you call it as hepatopancreatic ampulla with that sphincter. So that was about the gross location or repeat of the topic we have to discuss. Now we have to see that if we cut this portion and bring under the microscope, what features we are supposed to look at, right? Okay, let's find some other related diagram. That was about a duct system. Okay, this portion is just to show you the body of the pancreas and the tail. And here you know there lies the spleen, right? Okay. Okay, let's see a smaller portion of it examined under the microscope. You can see so many acini all around. So from this we learn that this is a gland which is having the exocrine part and endocrine. Exocrine, this main bulb is supposed to produce pancreatic enzymes, and the endocrine part, which you observe as a lighter stained area intervening scattered among this exocrine part, is the islets of Langerhans. This is the area that has to work like an endocrine organ and to produce hormones. That is visible. So if we complete this picture, we get a thin connective tissue capsule all around the pancreas, right? Okay, because we learned that there must be a capsule around any organ, especially with the endocrinal function. So that capsule is supposed to give septum for the partition for the passage of neurovascular bundle, right? Okay. And what it has to do, in addition to give support, it will bring the main pancreatic tissue into various lobules. We will see some other large view where we see various lobules, right? And the endocrine portion is also separated. This whole islets of Langerhans are separated from it through the reticular fibrous covering. Either you just name them as reticular fibers or they act like a capsular covering to separate it from rest of this exocrine. Not in a true sense that complete capsule as such nahi hoga, but reticular fiber itni well developed hai कि they are separating this endocrinal portion from the exocrine part. Okay, And again, what should be compulsory with the endocrinal part, that it must be having the inner related blood vessels. Capillaries कह लीजिए, repeated arteries होंगी, arterioles they will be changing into, and then later on converted into capillaries, because we know it is a ductless portion, so it needs some blood vessels to pour its secretion, which are hormones. Right? We will focus later on. Now, okay, still, if we continue, we can see so many collection of acini. The variety of the gland here is the compound tubuloacinar. In general term, if we ask what type of gland here it is. Okay, compound tubuloacinar means branching and rebranching. Specialized ductal system is there, and that tubuloacinar means the secretory part will be either in the form of a tubule or in the acini. Acini just like a bunch of grapes. Okay? जैसे आप एक अंगूरों का गुच्छा पकड़ के खड़े हो, the main stem would be the main duct, and so many small ducts are joining that main duct, which is here a pancreatic duct, right? And those small grapes act like an acini, right? You get the concept, okay? These acini, if I can give a boundary, have got so many pyramidal shapes cells in it, in a single acini. And they are purely serous in secretion. You hardly find any mucus secreting area. All are them with the serous secretion. So serous secreting, you would say acini, how they look like, they have got inner pyramidal cells and the basal darkly stained nuclei, right? Which is in contrast very different from that of mucus secreting, in which the nucleus is towards the periphery. We will see it later on. Here these are very well marked and they are showing intense basophilic staining. We know the nucleus takes it, and the nearby organelles, they also take the this darkly stained area like rough endoplasmic reticulum if it is there, ribosomes if they are, or supranuclear position of Golgi complex. And a striking thing that the center is addressing the eosinophilic stain. The apical region of, let me mark if you cannot get this. So see if we concentrate with this acini, again, like this, they are dull stain. So these are basically the pyramidal shaped cells like this, so many in a single acinus. I was talking about this darker stain nuclei, which could be basally located or take a little bit central position. Okay. And so many organelles, they give the intense basophilic stain. But we observe that this apical region is showing the eosinophilic stain. So there lies the granular network, okay, zymogen granules you would say, and they carry the pancreatic enzyme in it. So the single pyramidal cell is showing intense acidophilic stain at the apical region, and the basophilic stain, reason we know that the nucleus is there and loading with so many organelles. So this is the simplest explanation why we get different stains in a single cell. Okay. This is one acini, and in its center, the special thing about this pancreas, that it carries centrally lying cells called as centroacinar cell. The self-explanatory term, that center of acini. So centroacinar cells, what they depict, they are basically made up of simple squamous or low cuboidal epithelium, and they show the initial segment of the duct system, right? Imagine that there is a grape and we have got a first branch, right? That acts as a intercalated, right? What is the meaning of that intercalated? Intercalate. Inside, right? Coming through and through, right? If you imagine that there is an orange and you put a straw in it, the portion that will be inside that orange, that would be calling as intercalated, right? You are taking an orange, like a juice of orange, right? And you put a straw, and the portion that remains inside of that straw will be the initial segment of the first duct coming out through various acini. Is it clear now? This is intercalated. Now just at the base, I am putting this as the intercalated. There lies the centro-SNR cell, and when the intercalated duct portion is getting out, it is again lined with the simple cuboidal epithelium, right? And from this, and if I get another thing, and I draw, there are so many SNI like this. And if we see that two intercalated ducts, they are combining to form a single, it will be becoming the intralobular duct, right? So many intercalated are now small roads or like streets, they are joining towards forming a bigger roads. Okay, so the intercalated duct from here and from here, they are now forming the intralobular. What it means, because we at the start said that there lies a capsule, and the capsule is supposed to give septa. It means that the portion it is separating would be a lobule carrying so many exocrine portion, right? Is it clear? So the duct still in the lobule is called as intralobular. You get the concept? Intravenous injection जैसे होता है. Inside the vein, intra, okay? You observe so many intravenous, and these are joining to form the interlobular, because now there is another lobule. You get the concept? Yes. Okay. In between two lobes, अब इसका रास्ता हो गया. Now it has become from intra to interlobular. Epithelium now here again is from simple cuboidal to low columnar, right? Okay. Now these so many interlobular ducts will be finally joining and enter into the main pancreatic duct. और वो किस तरह से आपको pancreas में दिखाई दे रही थी? If you observe its uncinate process, head, body, sort of, that was just like a fish bone, and so many small ducts are entering into this main pancreatic duct. You get this concept? Okay. That main when duct is being cut, it will be showing stratified columnar epithelium. So this is how the network of well-developed ductal system exists. Starting from the centro-SNR cells, then the intercalated, then the intralobular, and then interlobular. Finally, they will merge and open into the main pancreatic duct with the stratified columnar epithelium. Okay. Usually, we have seen that the duct system that just act as a conduit, just acting as a passageway. सिर्फ रास्ता देता है, कुछ नहीं करता. But here you will be seeing that these initial part of the centro-SNR cells and this intercalated duct, they are taking part and they are producing bicarbonates, right? And in a sense, they are making the inside juice in alkaline in nature, right? Okay. So let's see some concern diagram now again. You see the centro-SNR pale staining cells in the very center, and it is giving rise to finally the intercalated duct, right? Having low cuboidal, you would say, the epithelial cells, and now they are from here and from here, they are joining to form the intralobular, right? And you can see a well-developed epithelium here, जो कि squamous या low cuboidal से normal cuboidal epithelium की तरफ change हो रही है. Is it clear? The concept, if I draw so many SNI, and you can see the passageway of these, right? Okay. Again, in repeat. Okay, this portion in the very center, either with this trichome stain or this is the HNE stain, the area in the center is showing the lighter one, the islets of Langerhans, and they are having the reticular fibers on its margins. And inside you observe the blood capillaries, and these cells are polygonal in shape and supposed to produce hormones. They have got, usually they are unseen, unstained, but if we treat them with some aldehyde fluorescent stain or trichrome, they will be showing their color scheme. And we have learned that they are various varieties, like alpha cells. They are supposed to produce glucagon, right? And they should be on the periphery of these islets of Langerhans, right? And then we have got beta cells. They are supposed to secrete insulin, and they occupy the central region, right? And their action is opposite, you know, the glucagon and the insulin. Then comes the delta cell that is supposed to produce somatostatin. Then you also observe the PP cells, pancreatic polypeptide, and so many others could be a part of it. But these are the main cell series that will produce enzymes, sorry, hormones that will act upon in your body to maintain the blood glucose level in special. Okay, this is just showing why the body and tail is shown, because this area will maximally showing the islets of Langerhans. If you cut so many portions, these two areas will be depicting the islets of Langerhans bundle. Okay, this is a typical look of an SNI. This is a pyramidal shaped cells, and you can observe the zymogen granules at the apical region. These zymogen granules are laden with the various peptidases and lipases, alpha amylases, nucleases, and you can see they are in the form of inactive form like trypsinogen, chymotrypsinogen. And a question can arise if your pancreas is filled with this much enzymatic bundles in it, why it is not being auto digested?
Inactive form.
Yeah, very good. Any other reason? Yes. Yeah, you can say that these are packed as an inactivated form in your
Zymogen
pancreas.
forms.
Allah has made your body accordingly, right? Your because this trypsinogen is supposed to convert into trypsin,
Trypsin.
right? Through various endopeptidases, which are
Enterokinase.
supposed to be secreted or become activated when they have to reach into the duodenum.
Duodenum.
The duodenum carries, if you can recall, the enteroendocrine cells. Yes, Kendra? So they were supposed to produce their secretion. They cause the activation of these inactivated enzymes of pancreas. Pancreas ने अपने ducts के through सारी secretion लेके duodenum तक जाना है. Duodenum के cells ने इसको अपनी secretion के through modify करना है और इसको फिर activation करनी है. So why pancreas is not auto digested? Because one of the good reasons could be that they are packed with the trypsin inhibitor in it. One of the reasons, and the activity of their enzymes is restricted to the duodenum. जब ये duodenum में पहुंचेंगे तो ये बम फटेगा, right? That is filled. Auto digestion नहीं होती. But in some autoimmune diseases, the story becomes in a reverse fashion. ठीक है? फिर पेंक्रियास की डिजीज स्टार्ट हो जाता है ड्यू टू अंडरलाइंग एनी पैथोलॉजी, कोई इन्फ्लेमेशन हो गई है, कोई गॉल स्टोन है, कोई अल्कोहल की इंडक्शन में है, कोई ड्रग इंड्यूस रिएक्शंस हो रहे हैं, सॉर्ट ऑफ कुड बी अ पार्ट ऑफ एनी एक्यूट रिएक्शन, acute pancreatitis, and if it is being neglected, it's having a very severe epigastric pain presentation would be, and if it's left untreated, sometimes it may be a warning sign of a malignancy inside. Usually it is not diagnosed in its early stages. When it gets involved all the material of the pancreas, later on it is being diagnosed, and the malignancy cells, malignant cells are supposed to be spread due to the sparse connective tissue inside and the vascularity. They will aid and it will get spread, right? And now here in this picture, you can see the centroSNR cell. Another good reason, because we have known that known about this, that these centroSNR cells, they and intercalated duct, they are supposed to form the bicarbonate. So these are forming the acidic secretion, but they are giving the neutrality here, the bicarbs, right? So there is a well inbuilt mechanism here that they shouldn't work inside the pancreas, right? Because टू थ्री थिंग्स। एक तो इनके बायकार्ब्स जो है वो इनको न्यूट्रलाइज करने के लिए अंदर बैठे कि यहाँ पर नहीं अपनी एक्टिविटी करे। दूसरा, इनकी एक्टिविटी स्टार्ट ही ड्यूडेनम में जाके होगी। अल्लाह हैज मेड आवर बॉडी सो। तीसरी चीज कि इनके साथ इनहिबिटर पैक्स थे जिनको ये काम नहीं करने दे रहे थे। आई एम emphasizing on this because the question can come in this form that a patient comes with so and so pathological condition and you have to treat accordingly and mention the reasons. Yeah, this is a larger view of the whole pancreas, and if there is a connective tissue that could be sending septas, and that septa definitely will be addressing some artery, some duct system. You can observe the word D, that is meant to show the duct, and these lighter stain areas are showing the islets of Langerhans, and intervening these lighter areas will be, these lines are marking the septa placement, and we observe various lobules, right? And this could be this could be a vein here and here, and when we observe the clear epithelium, either cuboidal or columnar, that could be a duct. Okay. This is an electron microscope to show the acinar structure. Again, a little bit more clear picture to show the schematic representation. These are the septas, these are the blood vessels inside, and that could be a sensory. The epicene and corpuscle is lying in between, and you can see there is the interlobular duct because we know the ducts through their epithelium, right? If the epithelium is simple squamous, we can focus it as a blood vessel or could be centroacinar, but if we get some cuboidal epithelial, that could be the major interlobular duct, you would say, or if stratified columnar, we will call it as major pancreatic duct. These lighter stained areas are islets, and these are the exocrinal acini. This is a microscopic view. We will see the microscope as well. Okay, that schematic representation is again showing very clearly the acini, the islets of Langerhans, and the various ducts. So very clear to understand. This is again a gross picture of the location of the pancreas. Now you can again observe the duct system. Can you see that it very much resembles with that of fishbone? The central pancreatic duct and so many smaller ducts are joining, and you can see various acini around them. In islets of Langerhans, they have shown on that bigger chunk. Yeah, this area is showing the islets of Langerhans with alpha cells in the margins, the beta cells to produce insulin in the center, and intervening could be the delta cells and other cells when it gets stained, right? Okay. Again, another picture to show you the alpha cells for glucagon, the beta cells for insulin, the delta cells for somatostatin. So this is how they are being thrown inside, and the F cells to secrete. They are called as PP cells or F cells, right? One and the same thing. They have to secrete pancreatic polypeptide. Okay. Again, a similar picture to depict various views. That is a clear picture for the complete gross appearance of the pancreas with the body, with the tail, with the head and main pancreatic duct, again opening into the second part of duodenum. Any related picture, if it comes in the way, I will discuss. That is the mechanism that how the chymotrypsin, the chymotrypsinogen has to convert into chymotrypsin, and the trypsinogen is supposed to be into the trypsins through various enterokinase that are being located in the small intestinal epithelial cells. That was just to show the mechanism to make you clear. Okay, these are the just name in the chart form that pancreas produce pancreatic proteases, the amylases and lipases, which we mentioned, to digest various three things, the carbs, the proteins and the fats. Okay. That is a larger view to show that is a single SNI. You can see zymogen filled apical granules in the apex. This is the nucleus, right? This is the pyramidal cells. In the very center, central located centroacinar cells, they are forming the intercalated cell because another duct, they are also coming, and intervening blood vessels are also there. This is just to make you remember that they are just like that of bunch of grapes, right? Okay. Again, either if tubuloacinar, so a light, larger or elongated view, just like that of it. That is just to make you remember that it is just like a fish bone, right? So it will be clear, not to forget. So thank you. Just the thing that is left is the slide. Yes, the most important part on 4x, because the schematic thing is a little bit different from this histological view. So kindly concentrate, we will start from one end. That could be all around the connective tissue, then, and it would be putting these the lighter stained area as a septa, right? To divide various main portion into lobules. And what you get? You can have the blood vessels nearby, some adipose tissue you can observe, and all these darker collection are the SNI. They are to produce the enzymes, right? And intervening there could be, if I can enlarge it, you can observe various epithelium to show that there could be a duct intervening. That could be a duct as well. So in this way, we can observe various portions. In the central connective tissue, you again find could be artery, could be a vein, and various other blood vessels and the ducts. And yeah, in this view, this is the collection showing the islets of Langerhans. This portion, let me make it a little bit more clear. These are the collection of islets of Langerhans, the epithelioid spherocyte cells. This is again a lighter stained area to show the islets of Langerhans. Okay, let's rotate. This is the bulk showing the adipose tissue, intervening adipose tissue, right? Okay. These are again in this darker stained exocrinal part. These are the lighter stained area showing the islets of Langerhans. Okay. Now we have to make it on 10x. Okay, now you can see these are the SNI either in a tubular form or in the acinar form, and these are the basal nuclei and apical area filled with zymogen granules. Intervening, that could be, if I make the cell boundary, that could be one of the duct. This is a bunch we have seen as the islets of Langerhans, right? When you observe at your own in the microscope, you will see the clear difference. We are rotating and we will definitely focus an area showing the islets of Langerhans. These are the cut section of blood vessels, various, and that could be a duct intervening. That could be first duct, could be the intercalated, and later on this is a larger bunch. We call it as islets of Langerhans. So why they are separated? They are lobules. Looks up, this is one lobule, another, an intervening septa. Well-developed connective tissue septa is always there. Yeah. Now you get another bunch in your observation as the islets of Langerhans. So that was all about for pancreas for today. Thank you.